Hi, welcome to the Family Home and Social Science Research Support Center Introductory STATA workshop. Today we are going to introduce you to some of the basic features and abilities of STATA. This workshop is meant for individuals new to STATA and those who would simply like a refresher course on some of the basics. Now, if at any time you feel that this video is going too fast, just hit the pause button and then resume the video once you've completed the previous steps or tasks that we have been on. Now, before we begin, we need to download all the files that we'll be using in this workshop. To do so, open up an internet browser. I'm going to use Google Chrome and go to our website at fhssrsc.byu.edu. Now, once you're on the home page, we're going to go to the workshops, and they are in the bottom left corner, and we're going to click on the link for the STATA workshops. Once there, you'll see the section for the Introductory STATA workshop. You go ahead and ignore the schedule, as that's our schedule to present here at BYU. And let's go ahead and download these three files right here. These are the three data sets that we'll be using in this workshop. Go ahead and click on entrance.dta, download it, place it in your downloads folder. This entrance.txt you will have to right click on and click Save Link As. The link has some issues, and for that reason you have to right click on it instead of just click normally. So again, with the entrance.txt, right click, Save Link As. Next, download the Flavor 2. Simply click on it, again save it in your download folder. And then for the command list here, go ahead and right click and open it in a new tab. This command list, as you'll see, has some of the basic commands along with explanations and descriptions of what each of the commands do. Now, as we go through the workshop, we will be using most of these in order. Some of them we will be skipping around with just because the orders have become better presented in a different fashion, but we'll go ahead and explain that as we get started. Now, let's go ahead and open up STATA. You can go ahead and do that in the Start menu. Mine is right here because I use it quite a bit, but if you haven't found it on your computer yet, just type STATA into the little search window and you should be able to find STATA 12, or if it's here, STATA 13. So STATA 12, here in this window, your screen should look almost identical to mine with exception of this main window here. I have my window set to a black and green color setting. This is the classic STATA setting. Yours is most likely a white and black. Don't worry, it's the exact same. Mine is just a little bit older of a preference for STATA here. Now to the left you will see the command window. That's this window right here and below. This keeps a log of all commands that you have either entered in here on the command window here, or that you've entered through a do file. We'll explain do files here in a little bit and be using one throughout the workshop, so don't worry. Over here on the right, you'll see the variables window. When we have a data set loaded into STATA, this window right here will display all of the variables and their labels, if they have any, that you have in your data set. Similarly, this properties window below will have your variable names and labels and their format types if you have a variable selected, and for your data set as a whole, it'll give you some descriptive statistics of that. Particularly of interest are the number of variables and the number of observations in your data set. Some other windows that are important here are the command prompt window here. While we will be using a do file for most of what we do today, there will be some quick commands that we'll use the command window here to enter in. I don't recommend using the command window for much more than these very quick, repetitive type entries. It's much better to have a log of what you're doing in a do file, or a syntax file as other people would call it. This main window here in the middle is the output window for STATA. This is where all of the output for all the commands that we have will be displayed. So if we run a regression or if we have any tables that we'd like to have printed out, all of that will appear here in this window. Up here you have your classic file edit type drop-down menus. Of import for STATA users are the statistics drop-down menu, from which you can do practically everything that we'll be doing today from a drop-down menu, or the data drop-down menu as well. We will not be using these drop-down menus today, as we'll be teaching syntactical entry into Stata instead of use of the drop-down menus. If you want more explanations about that, there are YouTube videos for it, and they also can be found online at Stata's website. Some other important things about Stata here are these icons, these one-click icons. You have your classic open, save, and print icons here on the left. And of import for us, we have the new do file editor icon right here, and you have the edit browse window here and the browse window right there. So let's go ahead and get started today by clicking on this new do file editor. You should get a screen that appears about like this. I'm going to resize mine a little bit so we can see Stata at the same time as we're typing. And I'm going to try and do some basic programming etiquette as we begin here. So whenever I start a new project or do file, I start off by giving myself some description of what's happening. So I'm going to go ahead and give this a description up top and say this file is for the Intro STATA workshop. Alright, now if I'm working with other individuals on a project, I will also add these other two lines which are very helpful for me. I will add a last modified by line and a last modified on line. So that way any collaborator or any person working on the project can know who was the last person to work with it and when did they do so. Also, in most of my files, I will leave a notes section. That way, if I have any notes to myself about where I stopped or problems I was having as I was working through an analysis, I can make those notes and catch up rather quickly on the next day's work. You'll notice, as I've been typing, that I did a / asterisk up here at the top, and then I ended with an asterisk /. You can also notice that all the text in here is green. That means in Stata that it is a comment. Stata will not try and read that green text as code. It'll simply pass over it knowing that it is comments to the user itself. There are a few other ways to make comments in Stata that we'll go over shortly. Before we do, let's go ahead and start writing our do file. I like to start every do file with the clear all command. If I've been working in Stata previously and pull up an old do file and want to start working on that project, this clear all command will clear all the data out of Stata that I've been using previously and will clear any macros or other preset features that I've had in there. So go ahead and use that clear all command. And then I always do a change directory command. That is done by cd, and then we can change to the directory that we'll be using. For those of you not so experienced with computers, all that means is I'm telling Stata where to access and where to find all the files that I'll be using. You can see right down here in the bottom left corner of Stata, this is the current directory that we're in. We're in the C drive, in the users folder, in my folder, in that users folder, and in my documents folder within my folder. Alright? Now, since we saved all of our documents in our downloads folder, we can open up an Explorer window here, and then click on our downloads folder. In order to get the file path, I can simply right-click up here on this bar and hit copy address. Okay, so once again, right-click on that top bar, copy address, and then I can go ahead and paste that into my line right here. Once that is in, all the commands that I will use in Stata, asking Stata to find a file for me and import it into Stata, or to save a file, will go to that command, to go to that directory that I've specified. So in our case, it'll be the downloads folder. In my case, specifically on my computer. For you, wherever you're at on your computer. Now, for me, again, we're using a do file right here, and then we'll be inputting everything into Stata from the do file automatically. I personally live by a little motto that says, if you haven't done it in a do file, you haven't done any work. The reason I say that is from personal experience as an undergrad, where I did entire projects in the command line down here, and every time I had to hop back onto Stata to reproduce something, I had to reproduce everything from either a Word document or from actually handwritten notes that I'd taken. take my advice for it. That's not the way to go. You do not want to use this command window solely and lose all your work. It's much better to have it up here in a do file editor, and that way you can save it and you can reproduce any analysis you've done at the drop of a hat. All right, so following my own motto here, let's go ahead and save this. I'm going to do a file save as. I'm going to save it in my downloads, and I'm going to call it Intro Workshop. All right, so we have that saved. Now let's go ahead and talk about some of these comment options. There are three basic ways to produce comments in Stata, and I hope that you'll use them today as we're going through the workshop. The first is by using an asterisk and then typing in any other line here in this line, the line that follows it. Another option is using a double forward slash, and this one is a little bit different in the fact that if you use a doubled forward slash, you can actually use it on the same line as code. So I can put in some age, we'll get to that later, but then I can write in some code here of saying summary statistics for age. Whereas if I tried to do the same thing with an asterisk, you can see here this text did not appear in green and hence is not commented out. Those are just two of the differences between an asterisk and a double slash. Now, if you want to do something more aesthetically pleasing, lots of people, when they code in Stata, will make nice little boxes like this that have notes written to them, to themselves in it. And they'll just simply say, you know, just to have it look pretty and say, you know, note to user. Please save files in C drive, right? So I mean, these are just simple ways that you can make things look a little nicer as you're going through. We could finish then with all asterisks underneath, something simple, just makes it look a little prettier or anything of that nature, right? So there, make that look nice and aesthetically pleasing. That's something that you can do. Just whatever is your own motif or whatever your own aesthetic feeling is, make sure that your do files are clean. You need to read them, other people need to read them, and the more readable they are, the easier it is for you to work in Stata. Alright, so now that we have some of these basics down, let's go ahead and start with some general options. Previously in Stata, lots of people would use the set memory command if they were bringing in a large data set. In Stata version 12 and above, that option is no longer needed. Stata will actually automatically adjust the memory allocation from your computer in accordance to the size of your data set. What Stata will not do is it won't adjust the max variables allowed. Now, depending on your version of Stata, that could be very different, but for most of you working at a university, that's going to be Stata SE or one of the larger editions of Stata. Now, let's say we're using a really large data set and we're maxing out on variables, meaning that we try and load in our data set and Stata gives us an error. What we can do is we can say set max var, and we'll set it at 30,000, which is the actual maximum for Stata. Alright, now once again, I wouldn't recommend using this unless you run into that error, but it is an option that you need to be aware of just in case you are using rather large data sets in the future. Okay, now that we have some of these preliminary commands out of the way, the clear all command up here and the cd command here, let's go ahead and bring some data into Stata. We're going to go over three ways to get that done for three different files. The first command we're going to use is called an in-file command. Now you can use your command list here in your browser. It's this command here in the third little box. If you want to save some time, feel free to go ahead and copy it. So you can just right click and copy, or you can use the shortcut of Control-C, and then you can paste it here into your window by right clicking paste or by hitting Control-V. Now we need to explain what this does. So the in-file command is saying to Stata, I want to bring in a file, and in that file there are variables with the names ID, gender, age, GPA, ACT, SAT, ACT, SAT, and athlete. Normally then you have a using statement, this is part of the code, and then you tell Stata where to find the file. Since we have already changed our directory to the place that our files are stored, we don't need this address, we just need the name of the file. So we can go ahead and delete everything up until entrance.txt, like I just did there, and then we can delete this last double quotation mark at the end. Once you have that in, you can go ahead and highlight that text in Stata and run it. So I should explain this before we do much else, but in a do file there's two ways of running code. One is simply to press the execute command. The other is to select the code you want and then press execute. The difference is when you have selected code and then press execute, Stata will only run that code that you have selected. If I have nothing selected and press execute, Stata will run all of the code. So to see all of these changes happen, let's go ahead and have no text highlighted and hit execute. As we check our output window down here, you can see that Stata has done our command from the do file, and that command has done, here's our notes, the clear all command. It's changed the directory to downloads, so you can see down here that our directory has now changed to C users my file and then in my downloads file. You can see our note to ourselves as well. It just prints out, nothing happens to it. And then we've set the maximum variables to 30,000 and we've brought in this file. So because we don't see any red, there are no errors, and we can see that Stata has inputted everything properly. So you can see here over in your variables window now that you have a total of 8 variables here: ID, gender, age, GPA, ACT, SAT, ACT, SAT, and athlete. Now if we wanted to look at those, a short command that we could type here in the command window is browse. Browse will allow us to look at our data just as if it were in an Excel spreadsheet. Now, as you can see, this looks pretty clean. Everything looks like it's in here properly, and we can see that our data is fairly clean and it looks good, right? Now there are two different ways to look at your data. I just showed you the browse option, which for short you can type BR and it does the exact same thing. It's a little abbreviated command for browse. The other option is edit. Edit and browse differ in one very fundamental way. In edit, I can change the entries in any cell. So now that I've changed that, you can see here in cell 1 that that entry used to be 39 but is now this large number. I personally will never open up an edit window unless I am absolutely forced to. The reason being is, let's go ahead and change that back. The reason being is that if I open up a browse window, so let's go ahead and open up a browse window. If I accidentally hit my keyboard and start typing, nothing happens. I don't know if you can hear me typing in the background, but I'm trying to type in and nothing will change in this cell even though I have it highlighted. Alright? That allows me to safely look at my data without the worry of changing anything. The reason I say worry is that if I have an edit window open and I accidentally hit something and hit enter, I cannot go back and change that. Alright, there is no Control Z to try and undo what I've done. But since I know what the number is, I'm going to go ahead and put it back in. And you can see in here, Stata has been making notes to us. As we have changed those in our edit window, Stata has told us in our output window here that changes have been made to the data set. First we changed it to that really large number, then we changed it back to 39, then again I showed you the change and we changed it back. Okay, so let's go back to our infile command and let's take a look at it. Infile is specifically for text files. A text file is delineated by this .txt at the end. Most raw data sets that you find on the internet or from other general data sources will come in either a text file or a CSV file. We'll get to the CSV in a second, but for now, infile is used for a text. Let's suppose that we didn't know much about the infile command and that we were trying to get help on it. An easy way to do that is here in the command window to type help infile. With that, Stata will pop up a help window here, and we can go ahead and click on infile 1 and look at the syntax. These help files in Stata are extremely useful. I use them every day and in every session that I work in Stata. I'm not a robot, I don't have everything memorized, and no one expects you to have everything memorized. So remember, whenever you're having problems with syntax, use the help menus. They are extremely useful and they're there for your benefit. You can see here the syntax gives you all the syntactical options for the infile command. You see the name of the command is infile, and then you see that you need to have a var list and a bunch of options here. One thing that I want to point out to you, there's a couple things that I want to point out to you. The first is in the actual command name, infile, you'll see a portion of the name underlined right here. The underlined portion of the command name is the shortest, most abbreviated portion of the name that you can type into a do file or the command line to have Stata recognize that command. Alright, so again, the entire command name is infile, but we could just type in inf, and Stata would recognize that command as infile. That's exactly what we did with the browse command earlier when we typed in browse the first time, and then for all the rest subsequent times we've typed in br, which is the shortest abbreviation for browse in Stata. Okay, so now looking at this syntax line, let's take a look at this, and we see that it looks kind of daunting to those of you new to Stata. But something that we should quickly point out is that anything in brackets, here, 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 or even these options, anything in brackets is optional. You do not need it to run the command. What is needed is everything that is not in brackets. So in order to run this command, we must type infile, we must have a variable list, we must type using, and then point Stata to the file name, either through a directory command or through the name of the file. So if we go back to our code over here, we can see that we did just that. We typed in infile, just like it asked us to here. We gave Stata the variable list of all the variables that are in our data set in the order that they appear. Then we added in the using command, and then we gave our file name. Our directory here was already changed, so all we have to do is enter the file name. And as you can see, that worked just well for us, and we've had Stata bring in our data for us. Let's go ahead and close this help window. One thing I want to point out about Stata is that while Stata is extremely powerful, it is only as good as the user operating the program. The reason I say that is because sometimes Stata will allow you to do things that aren't correct, despite the fact that they should not be allowed to be done. One example of that I'm going to give here is I'm going to take this text, I'm going to copy it, and I'm going to paste it right below. Now, I hit the wrong button. So copy, paste. Now what I'm going to do is I'm going to delete the variable name athlete from the code. So that way Stata doesn't know that there's a variable called athlete. I'm going to add on an option here at the end. So anything after a comma in Stata code is an option, and this comma clear is the option to clear out any data that's currently in memory and replace it with this new data. So let's go ahead and highlight that text and run it. You can see here in our output window, Stata ran it without any problems, but this time instead of 49 observations we have 56. A little bit interesting, a little bit different. Let's go ahead and visually inspect our data here by browsing. So again, I'm going to type BR and then enter. And you can see that our data doesn't look nearly as clean as it used to. We start out looking fairly good with an ID, gender, and age that looks somewhat appropriate, GPA scores that look appropriate, ACT scores, and an ACT-SAT score that looks well. But you can see here where that athlete variable used to be, there's no information. So what Stata has done, because we as the operators have misguided Stata by omitting the athlete variable in the variable list, Stata's taken the information from the athlete column and placed it here as the first value in observation number 2. And then it's taken the ID variable for observation number 2 and placed it as the value for gender. It's taken the gender value for observation number 2 and placed it as its age, saying that he's 2 years old, right? And so you can see that there's basically this candy cane effect here, this little striped effect, as everything is offset by 1 because this athlete variable is missing. Again, this is a user error. Stata is extremely smart, but it's only as smart as the people who use it. So let's go ahead and take out this. We're going to copy our text from above and bring it down here. Again, I'm using keyboard shortcuts. You can select and right click to copy and paste if you want. And then let's do our comma clear to clear out everything. And let's go ahead and run that code. You run it, you can see that athlete has appeared again. Our observations are back down to 49 observations. And if we browse our data, that looks like a much better data set. That looks clean. The genders look like a bivariate measure. The age looks very respectable in age. GPA, I don't have weird numbers like 19 or anything in my GPAs. And my athlete variable also is a dummy variable, right? So these are quick ways to inspect your data and make sure that it's been brought in properly. Okay, let's go ahead and use another method for importing data into Stata. And let's say we have a CSV file. We can check our downloads and we have this flavor2 CSV file. A CSV file is a type of Excel file called a comma separated value file. You can see that here in the name that it says comma separated value. Now many raw data sets will come in either a text or a CSV format, and there are two different ways. The text files we've already shown you are imported in the infile command, and a CSV file can be imported using an insheet command. So let's go ahead and copy and paste that from our command list here in our internet browser. I'm going to copy it. Actually, yes, I am going to copy that in. Now this code is going to need a little bit of work here. Let's delete this file path. And you can see here that we are going to bring in entrance.txt. We've already used the infile method for bringing that in, so let's go ahead and type in flavor2.csv, and let's delete the rest of that line. Now with this method, using the insheet command, we also want to specify clear, so that way we clear out any other data in Stata for us. And we can run that code and see that Stata has brought in our flavor2 dataset. In this method, the variables are not named, they're just given mock names of V1, V2, V3, and V4. But if we browse our data and visually inspect it, we can see that we have individuals' names, most likely something that has to do with age, and then two other variables, one being a bivariate measure and the other one being what looks to be categorical with 1, 2, or 3, 4 categories here. So again, if you have a comma separated values or a CSV file, the insheet option is your way to go. If you have a text file, or otherwise known as an ASCII file, the infile command is the best way to go. But there's a third option. If you have a Stata dataset, in other words, a dataset that has been made in Stata, you can simply type in use and then the name of the dataset. So we have entrance.dta, and we'll put in our comma clear again to clear out anything that's in Stata. And as we run this, you can see that we're back to our original text file, but this was our entrance.dta file here, right? The .dta is a file path specific to Stata, and it simply denotes that this is a Stata dataset. All right? So those three methods of entering data into Stata are your basic modes of importing data. Now that we're familiar with those methods, let's go ahead and start creating and modifying the data, creating variables and modifying the data set that we have in Stata currently. Okay? Before we do that, I'm going to make some notes to myself in this file. All right? I'm going to say right here above this line, I'm going to do a little asterisk and say correct method of importing text files into STATA. Alright. And then I'm going to put down here, I'm going to put as a little note to myself, missing athlete variable, but still runs. I'm going to put a little note that says, be careful, always check data. Alright, remember we just browsed. We can come down here to the InSheet command. I can put a little note to myself here and just say importing .csv file. And then here I can put in a little note to myself saying importing STATA dataset. Okay. I've put spaces between mine, just that's the way that I like it to look. You can do it again however you want, however it is clean and clear and readable to yourself. Alright, so let's go ahead and start. We're going to learn about the generate command. So generate command. Just giving myself a heads up about what we're doing. And let's go ahead and pull the code here from our command list. We're going to come down here to the generate line, and we're going to copy and paste this line right here. Generate FPC equal to 1. Go ahead and copy that and paste it here in your do file. Now, as we go, you can see that we use the entire word generate. If I use the help window and type in generate, help generate, you can see here that the shortest abbreviation that I need to use is G. You can see here these brackets I don't need to have in a type, but it's an option I could have if I wanted. And then I have to put in the new variable name, and then I have to put in an equal sign and an expression. Okay? So what we have here is we have generate our new variable name called FPC, an equal sign, and then our expression. In this case, we want all values of FPC to equal 1. So if we select that text and hit run, you can see that STATA has run that command and that FPC has been created. To visually inspect it again, we can type browse, and you can see here in the corner that FPC for every observation is equal to 1, just like we wanted it to. Now, there are more complex ways of creating variables, so let's try a different one. We're going to generate a variable called young female. So on your command list here, everyone go ahead and select this line of code, copy it, and let's paste it here to our do file, and let's talk about it before we begin. So the gen command, or generate, you can see here that the shortest abbreviation was a G, but I can also type in gen. I prefer this as it reminds me that I'm generating a variable, whereas if it was simply a G, I might forget what I was actually doing. So I typed in gen, and then I named the new variable. The new variable name is going to be young fem, short for young female. And then again I have my mandatory equal sign, and then I have an expression. And my expression is saying I want to generate a variable, young female, if gender is exactly equal to 1 and age is exactly equal to 17. These double equal signs here again mean exactly equal to. The ampersand here means that it has to satisfy both this quantity and this quantity for age being exactly 17 and gender being exactly 1. Since I didn't specify a value here, STATA will automatically create a bivariate variable for us. So let's go ahead and highlight that text and run it. Coming back to our output window in STATA, you can see that there were no errors, and if we browse to visually inspect our data, we can see here that young female is indeed bivariate, with zeros for everyone that is either male or female and older than 17. You can see here in the case of observation number 11, we have a female indicated by gender equal to 1. She is 17, and she has been marked as a 1 in the young female category. Again, you can see that with observation 12, a different individual, but same characteristics of being female with an age of 17. Now, the generate command is very powerful, but there are some expressions and some methods of creating variables that are too complicated for the simple generate command. For those, there is a command called Ijen. That's next on our list. So let's go ahead and open up again our command list. I'm going to copy and paste the Ijen command here. Again, I'm using keyboard shortcuts. You can right click, copy, or it's Control C to use the keyboard. I'm going to come down here and type in my Ijen command. And let's go ahead and take a look at this variable really quick. I'm just going to bring it up to the middle of the page here. So Ijen is very similar to generate in that we're going to type in the command name, Ijen. We're going to name our new variable here called nm, our mandatory equal sign, and then our expression. The expression here, you can see the sum is in blue, and then we have gender exactly equal to 2, comma, by age. What this means is that we want to create a variable called nm, and what it's going to do is it's going to count or sum up the total of every male, or indicated in this case by gender exactly equal to 2, and it's going to do it by age groups. And this way it's going to do it by each unique age. Okay? So if we run this variable, or excuse me, if we run this code, again select it, click run, you can come over here, Stata has run it correctly, and we can quickly visually inspect our data by hitting browse and scroll over to our nm variable, and we can check the males here. Observation 1, he is a male, his age is 17, and we can see here that there are 4 males age 17 in our data set. Observation 2 is a male, he is 19, and you can see here that there are 7 males age 19 in our data set. Interesting enough, you can see here for females who are 18 that there are 6 males who are 18. So what this said is, even though this observation is a female, the information that we've created in our new variable called nm is telling us about characteristics about the males, her exact age. All right? Now that we've learned how to create new variables in either the generate or the Ijen commands, and please note, we have not exhausted, not even close, the options with Ijen. This is an introductory workshop, and we're simply getting your feet wet and allowing you to experience these commands in their rudimentary forms. Explore the help menus for Ijen particularly, and you will find many, many options, including standardized scores, row totals, column totals, and other such features that are very useful in articulating your data in specific ways. But for our case now, let's go ahead and exit out of our browse window. Let's come back over to our command list, and we're going to learn now how to replace values of variables that have already been created. We're going to highlight our replace command here in the middle. Again, we're going to copy it, and we're going to place it here in our do file. Before we do that, before we run anything, let's go ahead and label it and make a note to ourselves of replacing values in the variable age. Oh, not age, in the variable nm. Okay? So as we read through this command, we can see here the command name is replace. We're going to replace values in the variable nm, and we're going to replace them equal to 1 if the age of the individual is greater than or equal to 19. Again, we're going to replace, what are we going to replace? Values in the variable nm. How are we going to replace them? We're going to make them equal to 1 if the age of the individual is greater than or equal to 19. By highlighting that code and running it, we can see that Stata executed the command successfully, and again we can browse here and see in our window that all those individuals with an age 19 now have a 1 in that category. Another method for replacing values in a variable that has already been created is the recode command. Often the case when we have to replace multiple values at once, the recode command is much more efficient and better suited. Let's go ahead and copy the recode syntax here, and let's paste it here into our do file. I'm going to make a note to myself that I am recoding multiple values of gender at a single time. So here in our recode command, first we type in recode, then you tell Stata what variable you want to recode. In our case, it's gender. And then you give Stata rules. And each rule is encapsulated in parentheses. Here you can see our rule is that every value that equals 2, we want to change to 1. And our second rule is every value equal to 1, we want to change to 0. Thus making this binary variable dichotomous in the fact that it is zeros and ones, making it better for regressional analysis. All right, so if we go ahead and run that, again you can see Stata accepted the code, there are no errors, and Stata tells you here exactly what happened to your data set. It said 49 changes made. Again, if we visually inspect our data through the browse command, we can see here that gender is now composed of ones and zeros. Now, just as with the generate command, there are simple ways of recoding and there are more complex ways of recoding. Let's go ahead and close this browse window, open up our command list again, and let's copy and paste this second recode command here. This one's a little bit more complex, but not too much so. I'm going to paste it there, and again I'm going to make a note to myself this time just to use variety, not because I like one or the other better, but just so you recognize that both can be used. I'm going to use the asterisk, and I'm going to type in recoding age and creating new variable old. So what this command here does is we're going to recode, and we're going to recode the variable age. And our first rule says, for any value between 17 and 18, we want to make that 0. For all other values, we want to make them equal to 1. So this else means 17 or 18, and all other values are equal to 1. This comma here, again, delineates that we've finished the basic code here on the left, and we're now going to have an option. The option that we've used is the generate option. So we're going to generate a new variable, and in parentheses we've put the new variable name. In this case, it's called old. So again, this code is going to take age, the variable age, and it's going to make all the values of 17 and 18 equal to 0, and all the other values equal to 1. Now instead of modifying the variable age, it's going to make all those changes happen in a new variable called old. Let's go ahead and run that. So again, highlight, click run. And you can see here in Stata that 49 differences between age and old. And old here has been added to our data set. So we now have 12 variables in our data set, and it's been labeled by Stata automatically as a recode of age, just as a reminder to us that we created this variable through the recode command. Okay, so that just about does it for the introduction to replacing and recoding variables. Now let's suppose that in our data set we want to decrease our sample size. We want to take out some of the observations that will not be very useful for our analysis. There are ways of doing that, and one way of doing that is called drop. So we're going to drop observations with a GPA lower than 2.0. The way we're going to do that is we're going to say drop if GPA is less than 2.0. All right, you can see this command, I typed it in here. It's also right here on the command list. Exact same command, I just typed it in here. Now, when we run this command, let's say we don't want anyone with a low GPA in our data set, we run it, and we come back to Stata, see that it was executed normally, but that 0 observations were deleted. All right, we can change that. Let's say we actually just want the high achievers, so we say 3.5. If we now run that command, you can see that 33 observations have been deleted. All right, so if we browse now, you can see our data set is much smaller. Now, let's say that we made a mistake. We didn't actually want to drop all those 33 individuals from our data set. We just put in a 3.5 and now we want it to be 2.0. Well, that's where you're in luck. If you've been doing your work in a command line, you would have to go back and physically recreate all the work that we've done. But since we have a do file here on the left, I can go ahead and highlight everything above that we've done and click Run. And now we're back to our old data set with 49 observations, and all the commands, including all of our new variables here, FPC, young female, number of males, and old, have been recreated. I just didn't run this drop command yet. So let's go ahead and change this back to 2.0 so we have our entire data set. And again, you can run it, and again we notice that no observations were deleted. Now, let's say that we created a variable, but we created it improperly. So for instance, the old variable that we have, if we created that improperly, we can drop an entire variable with the same command called drop, but simply specifying the variable name. We highlight that and click execute, and you can see that old has been dropped from our data set. Again, the difference in these two commands is not in the command name, but in the specifications that we use. I'm going to leave a note to myself that this is dropping a variable, while the other one drops observations. So a drop command with an if statement will tell Stata to drop observations. A drop command with simply a variable name will drop that variable, or you could have multiple variables and have them dropped all at once. Now that we've gone through and learned how to drop variables, we also might want to do some data management here and make our data set a little bit more accessible to other users. One way that we can do that here is by using the label command. So what I'm going to do first is I'm going to label an entire variable. I'm going to do that by typing in label. Actually, let's go ahead and use our command list here. So go ahead and click on your browser and let's click this variable here. We're going to copy it, paste that command here, and let's explain this code now. So the command is label. What am I going to label? I'm going to label a variable. What variable am I going to label? I'm going to label the variable gender. And what am I going to label it as? I'm going to label it as male. You can see here that male is enclosed in double quotes on either side. This means that that is text and should be read as text. Stata does not recognize spaces either in names unless it is enclosed in double quotes. So if I wanted to call this male equal to 1 and female equal to 0, you can see here that I have spaces. Without these double quotes, that would not be possible. So let's go ahead and run that command really quick, and we can see here over in our variable window that gender now has a label to it, that male is equal to 1 and female is equal to 0. But if we're sharing data with other individuals working on a same project, or even if we're going to approach a project 3 months in the future, leave it for a little bit and come back to it, we need to make our data as accessible as possible. So another option for labeling is to label the actual values of your variables so that way you know what they mean. In this instance, we need to create a label. Now, there are two steps. One is creating the label, and the other is labeling the values itself. I want you to think of a liter of soda. A liter of soda has a plastic label around the liter bottle, and it also has the bottle itself. Now, in order to label it, that label must first be created independently and then glued to the bottle to indicate what type of soda is enclosed in it. The same thing applies with labeling values. We first have to create our label. To do that, we type in label define, and we're going to call our label gender. Or we can call it, let's actually call it male. Okay? So we're going to say label define male. And then we're going to give STATA the code that we need. So we're going to type in 0, and then a double quote, female, and then a 1 and a double quote, male. What this tells STATA is it says make a label. So it says label. I want you to define a label. I want you to call that label male. And for every value that is a 0, I want you to take a rubber stamp and make that thing read female. For every value of 1, I want you to again take a different rubber stamp and stamp that value as male. All right? Now again, just like with our soda bottle example, all we have done is created that label. We haven't actually put it on anything yet. Now we want to apply it to our variable gender. So we're going to type in again label, and we're going to label value. Actually, we're going to label values. And what values are we going to label? We're going to label those of the variable gender. And what label are we going to use? We're going to use the one that we just created, and it's called male. So again, let's go through that. What are we going to do? We're going to label. What are we going to label? We're going to label values. What values are we going to label? Those in the variable gender. And what label are we going to use? The one that we created up here called male. Now let's go ahead and run those two lines of code together. Again, we can see here that STATA has read everything correctly. There are no errors. And now, if we browse and visually inspect our data, we can see here that our gender variable has been labeled. You can see that the font here is blue, meaning that the numeric value is still present, but visually, as we inspect the data, STATA will put a rubber stamp over that value, telling us a description of what that value means. So this is very useful if you're ever going to run analyses, and again, like I said, if you leave the data for a long time and come back to it and don't quite remember what things are, what categories are, you can label those values so that way you have a visual representation of what they are. And it leaves in the numeric properties for any use in any future analysis. Now let's go ahead and close our browse window, and just for sake of consistency, let's add some notes here. I'm going to say labeling variables for this first one. And then again, the second one is creating a label to use later. And this one is using our above created label to label the values of, oh, if I could spell values, to label the values of gender. Obviously, I spelled label incorrect there. Oh, no, I didn't. I was right. And again, if I wanted to distinguish anything here in the coding that I'm doing in my do file, I can make this stand out a little bit more by putting up here a big thing of labels. That way, you know, this isn't mandatory, but for me, as I go through, oh, hey, look, this is my labels section, and this is what I'm doing. It just stands out a little bit more. You can do however you please, just showing you some options for future work and cleanliness in your do files. But let's continue in our workshop here, and let's start working on sorting variables. The next 4 commands that we're really going to use are about managing the variables you have. The first one is sort of useful in an introductory sense, but will become much more useful in more advanced STATA coding. It's called the sort command. Now the sort command is going to do exactly what it says. It's going to sort. Let's tell it to sort by gender. If we highlight that text and run that in STATA, again you can see that STATA ran that properly. Let's visually inspect our data, and you can see now that all of our observations have been sorted by the variable gender. All the females, or the lowest value, here indicated by a 0, are first, followed by males of a higher value, here of 1, second. The same thing could be done if we deleted gender and said age. We could highlight that and run that, and you can see here in our browse window that our data is now sorted by age. Again, lowest to largest. So we have all those who are 17 years old, you have all those who are 18 years old, 19, and so on and so forth. Now, as I said, the sort command is somewhat useful to visually inspect your data, but it is extremely useful in more advanced coding in Stata, such as the Ijen command where you want to do by sorts and those options in Stata. We will not get into those today, but feel free to go onto Stata's website or our intermediate tutorials and look them up. The next command that we're going to go over, let's first close out of our browse window. The next command is a list command, and this is simply a way to look at information in your data set within the output window in Stata. So let's go ahead and say list SAT. If we run that, so again highlight and run, you can see here that Stata needs us to click the More button. We do, and more output is given to us. Here, Stata has listed all of the values with the observation number on the left, with a missing value interpreted as a period, and all the values here of each individual's SAT score. Now let's say that we didn't want to list the entire data set. Many of us will be working with data sets with observations in the thousands or tens of thousands. I would not want to look at that list, and in my output window, I may just want to look at the top 10 or the top 20. In order to do that, I can use an option in Stata. I can say list SAT in 1 through 10. This in statement here is simply going to tell Stata, list those observations in 1 through 10. I could have done 1 through 20, I could have done 5 through 15, or whatever range I wanted. We'll use 1 through 10 now for convenience. You can see here we have observation 1 through observation 10, and Stata has listed the values of SAT for us. Another useful command for managing your data set is the order command. Order will simply change the order of your variables in your data set. Over here in your variable window, you can see currently that ID is first, gender is second, followed by age, GPA, ACT, SAT, and so on. Now let's say that we actually wanted age to come second, we wanted gender to come third, and then we wanted ACT, SAT to come before GPA. What we could do is we could simply type in here in our do file, order, and then type in the order that we'd like. We'd like ID, age, ACT, SAT, and then GPA. If we highlight that and run it, you can see here that the order of our variables has changed. Again, if you wanted to visually inspect that, you can browse and see that the order of the variables has changed, whereas their values have remained the same. This can be extremely useful when you are using a particular set of variables repetitively in a large data set and don't want to search through the entire data set for those variables every time. It's something that I've used at times, and other people don't use it at all, but it's there for your convenience. Finally, in this process of cleaning our data and making it more presentable, it is often the case that when we download data from the internet, either from original sources or from secondary sources, that when it's downloaded and inputted into Stata, we have some errors. A common error is that variables that are supposed to be numeric are entered into Stata as text. While our example here doesn't have that happening, we're going to create a variable that does have that happening. So we're going to go ahead and type in gen. We're going to create a new variable. Let's just call it old. Again, just making that variable that we deleted earlier. And this time, again, we're going to have our equal sign, but we're going to have text here. And we're going to have everything equal to 1. Now, I'm telling Stata to make it a text entry or a text value by enclosing the value in these double quotes. Again, you can see that the text is red, indicating that it will be read as a string. If we highlight that, run it, you can see that Stata ran it, old is now part of our data set, and if we browse, again I'm going to use the command line and type in br. If we browse, let's scroll over to the end of our data set, and you can see here that old is in red. These variables here, the values, while it says 1, are all red. If we look at the variable properties window here, you can see that the type is str1, which signifies that it's a string type 1 variable. Now, string variables are interpreted as text and cannot therefore be used in any regression or any other type of statistics. That's not what we want. Let's go ahead and close this browse. We want that to be read in as a numeric value. In Stata, if that happens to you, you can simply type in the dstring and then list the variable that you want to dstring. I should remember here in R, in my dstring command, I almost typed in dsting, which is not correct. So if we highlight this dstring command, again dstring and dstring what, the variable old, and run it, we see that we get an error in Stata. Now, it's been a while since I've used the dstring command, and I can see here that I might have to look it up. But the error tells me that I must specify either generate or replace option. So I know that that means that to have an option, I need to put a comma, and let's go ahead and write replace. So what that means is that as I'm taking the string values of old and replacing them with numeric values, I'm going to replace the variable old with the new variable old with numeric values instead of string values or text values. The generate option would leave old as an old variable and generate a new variable with the numeric values. So let's go ahead and run that. And again, you can see that old has all characters numeric, and they have been replaced as byte. That's just simply another type of variable in Stata. If we visually inspect the data, again by typing in br for browse, and looking at our data here, you can see that the variable old, these values used to be read because they were string values. Now, as we look at them, we can click on one and see that the properties here are byte values. This means that it is now recognized in Stata as a numeric value and can be used in any regressional analysis. Again, in our case, we had to create a string variable and then destring it. But it's often an occurrence in downloading datasets from the internet or from various sources that for one reason or another, unbeknownst to us, what will happen is a variable that's supposed to be numeric is loaded into Stata as a string. Simple fix, dstring, variable name, comma, and then whether or not you want to replace that variable or generate a new variable with those values now as numeric. As a side note, you may have noticed that I have not been using this command list. All of these commands are in the command list. I have just been taking them out of order a little for the purpose of simplicity and streamlining the process into different categories. But now, moving on, let's go ahead and start a section for investigating our data. Often the case, you'll hear a professor or you'll be told to investigate your data or get to know your data. And this is often done by looking at summary statistics or otherwise known as descriptive statistics. In Stata, there are a number of ways to do that. Let's start with the summary command, or for short, sum. So let's actually look at let's go ahead and look at our command list here, and we can see here the summary command. And let's just go ahead and highlight that, sum GPA, copy that, and paste it into Stata. Now, if we sum GPA, we're going to see here in Stata that we have some actual output that we can read. And here we get the number of observations in the variable GPA. We get the mean value of GPA in our data set, the standard deviation of GPA in our data set, and we also get the minimum value and the maximum value of GPA in the entire data set. Now, while this might be useful, STATA also allows for us to get more information through the summary command, and that can be done by simply specifying a comma D. I'm going to place a new line of text here. So above we have the classic summary command, and below it we have the summary command with sum. We're going to sum the variable GPA, and then I'm doing a comma to specify an option, and the option I've specified is details. The abbreviation for details is simply a D. You can type in details or a D. They will both run the exact same. So let's go ahead and highlight that and run it. As we run it, you can see here still above is the output for our normal sum command, and here below is the output for our sum detail. The difference being primarily on this left-hand side. This left-hand side gives you the percentiles and the values in those percentiles. So we can see that in the first percentile, the value in the first percentile of GPA is 2.0. The value in the 50th percentile is 3.32, and then in the 95th percentile is 3.38. Also of use, STATA gives us the lowest 4 values and the highest 4 values of the variable. Again, as with the normal summary command, you get the number of observations, you get an observation weight, and here, just like above, you get the mean and the standard deviation. Differently than below, than the normal summary command, you get skewness and kurtosis values. If you haven't been introduced to these topics yet, you will be in your statistics class. They're simply values that help us understand the distribution of a variable. Don't worry about them for now, but know that you can find them in the sum with the D option or detail option. Now, another way of investigating your data or getting to know your data is by creating tables. All right, these are often called cross tabulations or simply tables or other terms that are used for them. Now, the command in STATA is tabulate, or tab for short. We're going to use two variables today, and we're going to cross-tabulate ACT and gender to take a look at how ACT and gender vary. To do that, we're going to enter into STATA, tab, ACT, and gender. We're going to highlight that command and run it, and you can see here that we've created a value for, or we've created a table, I apologize, for ACT here on the left and gender on the top. You also see the label that we've given gender, and you also see the labels here for the values. If we had not labeled the values of gender, this would be a 1, and this would be a 0, and this would be a 1. In each column, you can see the total females who are age 18 or total males who are age 18. In the column on the right, you can see the total number of individuals of each age or the total number of individuals in each gender category here. Now, the tabulate command, or using a longer term, the cross tabulation, can be used for many, many different things. We hope that you will explore it with your own data and get to know your data as best as possible. But moving on, another way to investigate your data is through the mean command. What the mean command does is it estimates the true mean of a variable in your data set, and it also reports confidence intervals for you. So let's go ahead and look at our command list here. Let's go ahead and highlight the mean ACT command. Again, copy it, and let's paste it here to our do file. Highlight, and let's run it. You can see here that we have been given some output. The number of observations for ACT is 23, meaning that the remaining observations of our 49 total observations have missing values. We can see that the mean is 26.04. It gives us our standard error and our 95% confidence intervals, that being 2.5% on the left, 2.5% on the right. This command can be very useful in determining the distribution of a given variable. And it can also be useful simply in investigating the average scores or mean scores of each variable. Another way of investigating the data is to tell Stata that, or ask Stata to investigate the proportions of our data for each value of a variable. That is done through the proportions command. And let's look at age this time. So this way we can get a breakdown of our data set by proportion in age. Again, let's highlight that. Let's run it. And you can see here that for each age category, 17, 18, 19, and 20, we're given a proportion along with a standard error and a confidence interval of the proportion of our data set that falls within that level. Now, again, this is of the entire data set, and for each different variable, you will have different proportions. Here we have a full information because it's 49 observations, and we have 49 total observations. If we were to do that with ACT or athlete or anything else, we might get a different story. Okay, now that we've investigated our data, we've cleaned our data, and we've learned how to manage it, it's time to run some actual analyses. Your general linear regressional analysis is run in Stata through the regress command. So we're going to regress, and we're going to look at GPA, and we're going to look at GPA as our dependent variable with independent variables of ACT and athlete. So again, the regress command, we could type in short reg if we wanted to, but here I've typed in regress. Our dependent variable is GPA. Our independent variables follow. So here we have ACT and athlete. If those terms are unfamiliar to you, don't worry. Again, you will interact with them in your statistics classes. Let's highlight that command and run it. We can see here in Stata that our output looks very funny and hard to read. Sometimes this happens, and it happens because the output window is not large enough. We can increase the size of our output window by either increasing the entire size of our window or by increasing simply the size of our output window within Stata. I've done both options to give myself a little bit more room, and because this looks so messy, I'm not even going to try and read it. I'm going to rerun the command by highlighting regress GPA ACT athlete, running it again, and you can see now that because we've increased the size of our output window, our results look much more readable. Up here you have your general information about the model. This is useful in creating ANOVA tests and in reading the fit statistics of the model. Below you have your slope coefficients for each variable. You can see here that GPA is listed as our dependent variable, and then our ACT and athlete are listed as our independent variables. This underscore cons represents an intercept or a mean value for our regression, and you can see here we have our slope coefficients and then our p-test for significance values. I will not go over interpreting these values as that should be done in your statistics classes. But what we will do next is we will help you understand how to predict commands. A regression model is a mathematical model to help us understand trends in data. So we know what trends have been formed, but if we wanted to predict where people would be, even those individuals who are in our data set, then we can do so with our new regressional model. To do so in Stata, we would use the predict command. So let's go ahead and try and predict GPA levels given our regression. To do that, we would type in predict, and we need to name our new variable. So let's call it guess GPA, highlight that, and run. You can see here that Stata has run that option, and that it has given us fitted values with 26 missing values generated. Those 26 missing values are due to the missing values in ACT. You can also see that our new variable guess GPA, which again is our predicted values of GPA, is now listed here in our data set. So let's say that we wanted to compare GPA and guess GPA. So let's go ahead and type in list GPA, guess GPA, hit enter, and we can look at our results here. You can compare now the actual results of GPA and our predicted results from our regression analysis. And you can see that our regression actually came fairly close in predicting individuals' GPA given simply their ACT score and whether or not they were an athlete. Now that we've done a regression, some other methods of investigating our data or looking at projections or anything else are through graphs. Two basic types of graphs in STATA are histograms and scatter plots. We're going to go over those next. First, histograms are done simply through the histogram command. I'm going to type in hist for short, and let's go ahead and look at a histogram of GPA. So this is going to be a histogram of a single variable, GPA, and as we run that, STATA has ran it, and if we wait, STATA gives us a graph or a histogram, our bar graph of GPA. And here you can see the number of individuals, or the density, as STATA calls it, of each category of GPA. But let's say you want to look at more variables at once. An easy command for that is to create a scatter plot of two variables. So let's look at GPA and ACT. Let's run that command and see what STATA gives us. So here you can see that GPA, the first variable in our command, is on the y-axis, and that ACT, the second variable in our command, is on the x-axis. If we wanted to reverse those, the x and y-axis, we would simply reverse their order here in the syntax. Now, let's use some options here in our syntax, and let's give this a title. Let's call our scatter graph GPA ACT regression. Alright, so now if we run this again highlighting so that way we run only that line of code, and clicking run, you can see now that our graph up here at the top has a title of GPA ACT regression. Now there are various other options with both the histogram and the scatter commands. Another method which we will not go over in this workshop is the graph two-way. The graph two-way is one of the most used graphing options in STATA. It's one of the options is the scatter plot. You can also do line plots and other such plots. What I would recommend if you are interested in graphs is that you log on to our website here at fhssrsc.byu.edu. Again, we're in the workshop phase, and scroll down to the intermediate workshop here, just below the introductory workshop that we've been working on, and download our PowerPoint and our do file. In this PowerPoint and do file, we do go over a little bit of graphs and so forth. Actually, the best graphing that we have is here in the visualization practice and the advanced STATA workshop. This is graphing for those who are 100% involved in STATA and want to have the best looking graphs in their homework, projects, or papers. That is it for today. We hope that you've enjoyed the workshop. If you have any questions, comments, or feedback, feel free to email us at our address. You can go click on the Contact Us page and email us at fhssresearch@gmail.com. On the contact page, you can also see our hours. My name is David, and these hours will change, so I might not be here, I may, but the individuals that work in the Research Support Center and their specialities in programs that they use are all listed below. Again, I hope you've enjoyed, and I wish you well. Bye.